Hello and welcome to Chill Phil Gaming, this gaming channel that's a little more chill. We like to keep it chill. I got my slippers on, I got a candle lit, my dog is sleeping in the background. In fact, we have some light rain happening right now that you'll probably hear in the background, but it's just real chill. We keep it real chill. So if you're looking to kind of wind down, this is the channel where you want to be. So give me a like, subscribe, follow for more, and leave in the comment section what you would like to see more of. We are right now doing Universe Sandbox, and I am going through the tutorials at the beginning because I'm learning as we go. So it might be kind of fun for you if you know a lot about Universe Sandbox, kind of watch and see how I'm learning and not doing very well. Maybe you have some suggestions for me. Leave them in the comments. If you have an idea for a future video, let me know. That would be great. Thank you, and let's get into it. Okay, so this is the second video. In the first video, if you saw that, I was doing tutorial 1, and we kind of made it into a bit of a meditation, and that worked out very well. I was super relaxed by the end of that video, and I hope today's is something similar. Let's go on to part 2 of the tutorial here. And we are here in part 2, and it says, our solar system has been reset back to normal. Let's explore the importance of our sun. Okay, let's do. Let's look at, oh, there's our beautiful sun. I feel warmer just looking at it already. The sun is the most important source of fuel for life on Earth, it says. What would happen if we got rid of it? Well, it would be a lot colder. We would lose that important source of fuel for life on Earth. Life would just kind of evaporate. And we are going to, it looks like, remove. So we click the tool and we click the delete tool. We're going to remove the sun, and it gives us that little trash can. We're going to stuff the sun into that trash can, and it's going to poof, disappear. And can you imagine what's going to happen if the sun is the big kind of center of our solar system, the source of gravity that is keeping everything in order in their orbit? If we get rid of that, then things that are kind of keeping in orbit are all of a sudden going to start going in a straight line away from that orbit that they were in. And we're going to click it and delete it. Here we go. Boom. And we zoom out and we see everything just zooming across, and look, Earth and Jupiter, oh, they might collide. They narrowly missed. That was very exciting. And there goes Earth, there goes Jupiter, here's Saturn, and Saturn's going in a straight trajectory now. And without our sun, this says, our solar system falls apart, as we see. Yes, that is correct. And Earth gets cold. Oh, so you see our land is no longer green and brown as it was, and now everything is snow and ice. It is just freezing over as we speak. Life as we know it would end. To see Earth's temperature, look at its properties, click on Earth to select it, and then we see down here, it is negative 64.4 degrees Celsius, and that is cold. And we're going to click on it further and just see some other things about it. We can see how the temperature is changing across the Earth's surface by opening the Earth's data view. So we're going to click on this, and it looks like we get 3 different maps. We see the Earth's surface temperature here, we see the elevation, we see the gas pressure. So we're focusing on the Earth's surface temperature here, and we see that it is all white with snow and ice, and that is cold. Now everything looks like the poles. It's just one big pole. Okay, these panels show detailed surface conditions across the Earth. Yep. Click on tools. We're going to warm up the Earth with a friendly laser blast. I've never heard a laser blast be called friendly, but if it helps us bring life back, then yes, it would be. So let's click laser, as it says, and minimize the tool panel. Thank you. And it helps me center Earth. And we're going to just blast it right in the middle here. Let's see. Boom. There it goes. Oh, whoa, that was something. And it looks like, if we see up here, we're getting mostly around north of Russia, trying to warm it up, but I don't think it's doing a lot of good because, look, it's freezing back over. All that warmth is going away. The Earth is still cooling rapidly. Maybe we could fix this by adding another source of gravity and heat, it says. So here we go next, clicking on tools, and we're clicking on add, and we're adding a star. So we are clicking on stars, and it's telling me to add the blue supergiant Rigel, which is quite a bit bigger than our sun, but our sun no longer exists, so we are trying to help it. And if we zoom out here, we can see where everything is going. Saturn is on its way that way, Jupiter's on this way, Venus and Earth are far over there, Mars, Uranus. It says now place Rigel where what used to be the center of the solar system. And I'm guessing it's where these two lines cross. If Rigel is bigger than the sun, then we might see something change in the gravity. Let's place it. And as we do, Rigel is a very large star, this says. It is 23 times more massive than our sun, right? This gravitational force should be enough to bring back the planets and warm them up. And as we can see, Saturn is doing a little bit of a U-turn. Jupiter is doing a U-turn because our gravity is pulling it back into Rigel. And we are going to click next. And is it going to take us to the Earth? Yeah, it doesn't look right. All the planets are being sucked in. Yes, as we can see, they're coming back towards Rigel. And eventually everything would collapse in on Rigel. Everything that is within Rigel's gravitational pull. Clicking next, and it takes us to Earth. And now the Earth is much too hot. Okay, that makes sense since Rigel is so much bigger than the sun. Maybe we made some mistakes and ruined our solar system. That's okay. There's always something to learn from an experiment, even one that ends in disaster. And we can always try to create life-sustaining worlds from scratch. Look, Saturn. Saturn might get eaten up right now, or it might get yeeted around Rigel. Here it comes, and boom, there it goes, and it's cruising. It's got a new orbital path, but Jupiter's going straight for it. Yeah, okay. Goodbye, Jupiter. Goodbye. Okay, we are going to continue. Man, everything's about balance, right? You need the right distance from the right size of star to keep an orbit. And a life-sustaining orbit is all about distance between the planet and the sun. It's all got to be in balance. They call it the Goldilocks zone, where it's not too hot, not too cold, not too far away, not too close. And that's what we're learning today. Balance. So that's good stuff. Here we are into part 3. In Universe Sandbox, you can create and adapt planets on your whim. And let's try terraforming Mars. Let's do it. Here's Mars. And Mars, for a planet to be habitable, it needs water. And we can manipulate the surface of an object, including adding water to it, using the planetscaping tool. Here we are down and adding. In the planetscaping tool, we're adding water, and you can add a lot of all these other things. But right now, we're going to focus on water and aim at the planet and press hold. Okay, so we're going to add some water here, and see, that's a mountain. We see an elevation. In fact, I think this right here. Anyone know what that is? I believe that's Olympus Mons, which is said to be the highest or tallest mountain in all the solar system. So if we go into, like, say this is more of a valley, look, the water probably stays there, but if we add water to the top of Olympus Mons, I don't think it's gonna stay there. It's probably gonna just, just come right off of, so we'll make Olympus Mons an island. How's that? Let's do it. Olympus Mons is now an island, but it's saying at this rate, we are not adding water fast enough. It's gonna take forever to create an ocean. So we're gonna do 2 times, and it's saying do 2 times again. So like a 4 times multiplier. And now we see we're covering a lot more distance with our water. So we're aiming at the planet, and we are adding water here and there. And top of Olympus Mons, let's make that an island. And here we go. And what we're doing is every time I hold on to this circle over there by this arrow fills up. So they're saying go as far, that looks like a little alien guy, but Okay. And we're adding water, and we've added enough water for it to move on to the next thing. Let's wait a few years and see what happens. Well, Mars is too cold, and this water is freezing up. So as we see, look down here, the years are going by. The water that we added started to freeze because Mars is so cold. As you can see, the water is frozen. We can try to give Mars shorter days so one side of it doesn't get too hot or too cold by making it spin faster. We can aim at the edge of the planet to make it spin faster because we want balance. Again, we want balance. We want the right amount of time spent in front of the sun or in the shadow of the sun in order to keep a regular temperature, the right temperature to warm it back up. But now it's saying, spin it, spin it, spin it. It's telling me to go all the way here as fast as possible, fill up that circle and spin it, keep spinning it. And then, yeah, we're way too fast here. Ah, really? We're still spinning? How long do I spin? Here we go. Here we go. Uh-oh. We made Mars spin so fast that gravity couldn't hold it together anymore, do you think? It turns out it can be hard to make a planet habitable. It sure can. So yeah, I mean, it just gets me thinking, like, what a rare miracle that we live on this planet, this one planet that we know of that has life, that is spinning at the right speed, that is tilted at the right angle, that is far enough from the sun. The sun is the right size, the right temperature, and here we are living and breathing. There are things growing. I have plants in my office. I have a dog in my office. And because of the right place in space in relation to a star and at the right angle, all these things, the Goldilocks zone, the right temperature, we can have and sustain life. And the beauty of it is that we get the benefits of that. The benefits of, I love my dog and he's right there and he loves me. And that we live in community with other people and in close contact with other people. And back to the game, we see that we are in the TRAPPIST-1 system, which is 40 light years away. And we've observed 5 planets. Scientists observed 5 planets that are similar to the size of Earth. Okay, so that size is good, right? And we want it to be habitable. So we see here, but even systems with many potentially habitable planets shown by the green region of the habitable zone are fragile. Okay, so this is the zone. This is the Goldilocks zone, this green region, this balance. And we find really that there's, 3? It looks like 3, and this one's just right on the edge. There's some red here. And we find 2 that are really in the good zone of it can be habitable. And so it's just super fragile, it says. And so we're gonna zoom in here. Say, select TRAPPIST-1 and open its properties, okay? And it looks like we're going to make it 2 times bigger. And what that's going to do is it's going to throw everything out of the habitable zone. We're going to lose our balance. And when we lose our balance, we lose this nice orbital ring in the green zone, and no longer are we in the green zone, and we're struggling to survive when we're outside the green zone. When we're in the red zone here, it's too warm, and we will just burn right up. When we're in the blue zone, it's too cold, right? And we're just freeze up. And so the beauty of this is that we live right in the sweet spot. That's one of the points, or a lot of astronomers want to see potential for life, potential conditions. Maybe someday we'll be able to travel to, I don't know. Can we make something habitable, terraforming and all that? But it just gets me thinking, because here, we're gonna do this and things are gonna go out of proportion. Double the mass by the 2 times multiplier, right? And then boom. Everything is fragile. Everything is fragile. And one small change creates a big reaction. One small change creates a big, gigantic reaction. And while one of the planets might be in the green zone like this guy for a long time with the wrong conditions, gets too close to TRAPPIST-1 and burns up right here. The rest of it doesn't matter because we've lost life, right? And life is the thing that brings meaning. So when I say doesn't matter, yeah, we could have all this beauty in the solar system, but if there's no one to appreciate it, does it have meaning? Does it matter? I don't know. That's a hard question. That's a question that you have to answer for yourself. But yeah, I mean, let's just kind of zoom in here and take a look. TRAPPIST-1. And is this how we slow down? Decrease target simulation speed. Here we go. So now we're going at 10 hours a second. Let's go down. Let's close the guide and sit here for a second. Closing the guide. Bringing it down to 4 hours per second, 2 hours. Here we go. Down to 1.3 hours to about 1 hour a second. And we can see how fragile life can be with one small change. And we're seeking balance in our life. And we seek balance by finding the right amount of things in our life. Maybe it's too much going on. Maybe it's going too fast. Maybe we need to slow it down. Let's even slow it down even more. 35 minutes per second. 23 minutes per second, 15 minutes per second down here, 10 minutes per second. Okay, and we're slowing down. And when we're in the green zone, let's take advantage of that time there. And you might be in a place, where do you feel today? Do you feel like you're in the green zone? Do you feel like things are going pretty good? Things aren't too fast, things aren't too slow. You're feeling pretty good about life. Maybe you're cruising in the middle. Things are pretty heated. There's a lot happening in your life. You're getting burned. There's some people burning you, maybe too busy of a schedule. Or maybe you find yourself out on the blue and you feel lonely and you feel cold and you feel by yourself. And we all end up being in these different spots at different parts in our life, different times in our life. And I think that's okay if we can have grace with ourselves. If we're too lonely, if we can discover it, if we can point at it and go, yeah, I'm isolating and I am too far out in the blue zone. I need to get back to the green zone. Then maybe we need to include others in our life a little bit more. Maybe we need to be a little more vulnerable, get closer to the heat. Feel the heat a little bit. Feel things, kind of the pressure building. And you might find yourself growing a lot in this area. You might just find yourself getting some energy, some light. And it might be too hot to handle. You need to cool off a little bit. So maybe it's going back into the green zone. And I think this is what our life can often be like as we're slowing it down here. Let's just zone in to this. Looks like something's happening here. Ooh, look at this. That's cool. What is happening, TRAPPIST-1? What you up to, buddy? Wow, that's cool. All right. So yeah, sometimes there's a lot happening in our life. Think about where you are on this map, basically. Are you in the blue? Are you in the green? Are you heating up in the red? Do you need to cool off a little bit? But don't get too isolated. Don't get too lonely. We need others in our lives. And these are good things. Life changes, fluctuates, life ebbs and flows, and we find ourselves at different points, at different times, at different areas of our life. In the green and blue and red zone. And it just takes a while sometimes to find our way back. So what do we need to do to find our way back? And that's what I have for you today. Thanks for chilling out with me. Hope you are doing well. Leave some comments. Let me know how I can do this better, what I should try differently. Leave a thumbs up and subscribe. Hit the bell. Stick around. I appreciate you coming out, and I'll see you next time. Bye.